Hello.
Hi.
Sorry, I made a mess of that meeting this morning. I put it as a different title.
Sorry.
Okay, let's get going. We're going to go through 7.3 right now. So I'll get started with that, and then I'll answer questions from 7.2, and then we'll switch over to physics about halfway through or whatever time we need. Okay? So we're looking at exponential functions, and we want to be able to solve exponential equations. So for example, if I have 2 to the x is equal to 32.
Can you move the camera down a little bit?
Yeah. Do you guys want to just throw her on mute for a sec, girls? Is that good?
Yeah.
Is that better? Okay. So I've got 2 to the x equals 32, and I need to solve for what x is. All right. So now in this case, I can do one of two things. I can graph them and graph y equals 2 to the x, graph y equals 32, and I can find their intersection point. One method to use for sure. So I go y1 equals 2 to the x, y2 is equal to 32, and find out where they intersect. A second method that I can use, if it's possible, is to get the bases the same. So the base in this guy is 2x. I can't change it. So it remains as 2x. But 32 can be written as 2 to the power of 5. So what I've done is I've changed the base on 32 because it works better. And therefore, if the bases are exactly the same, then that means the exponents have to be the same. So I get x equals to 5. All right? Okay? So this is the algebraic way of solving it. All right? But we know that it can't always happen. So for example, if you looked at example on page 251, the third example, I've got 7x is equal to 3579. And I find out that there's no way that I can put 3,579 to 7 to the power of something. So if I can't and find out where they intersect at. So they draw the picture for you on the graph, and using your graphing calculator, graph the function y equals 7x. So they did it a little different. They graphed it just as one graph. I would graph it as 2 separate graphs and find out where they intersect at. So you're going to have to change your window to make it quite large so that you can find out where the two of them intersect. Okay, so I'll come back to that one in a minute. So let's go back to 250. And on page 250, they want you to practice writing by changing the bases to a specific base. So looking at working example 1, I've got a is 32. So let's put it to its very basic base that we can possibly write it as. So that's 2 to the power of 5. B, 16 cubed. So I could write that as 4 squared to the power of 3. Or I could write that as 2 to the 4th to the power of 3, which would be 2 to the power of 12. Multiply your exponents together. I have the cube root of 16. Recall from last year, the cube root is written as 16 to the power of 1/3. So I've got 2 to the 4th to the 1/3, which is 2 to the power of 4 over 3. Again, you're just multiplying. So this whole first part is just refreshing your exponent rules. 1 over 64 is like saying 64 to the negative 1 to the exponent 1/3. So that is 2 to the 6 to the negative 1 to the 1/3. So that's 2 to the negative 6. So I multiply. 6 times negative 1 is negative 6. Negative 6 times 1/3. 2 to the negative 2. 6 times negative 1 is negative 6. Negative 6 divided by 3 is negative 2. So that's rewriting all of those as a base 2. Okay? Basically, all it is, like I said, is a review of all your exponent rules. All right. I have 10 to the x plus 4 is equal to 1,000 to the x minus 4. So what I want to do here is I want to get, if I can, I want to get the bases the same. So I have 10 x plus 4 is equal to 10 cubed x minus 4. Okay, so I've got 10 I can't break down anymore. 1,000 is 10 to the third. And so if my bases are the same and they equal on both sides, that means that my exponents have to equal. So I got x plus 4 is equal to 3 times x minus 4. X plus 4 equals 3x minus 12. Add 12, that gives me 16 equals 2x. X is equal to 8. Okay, so the exponents are equal to each other. That's that. All right. B. (25 to the 2x) equals 125 to the x minus 1. So we want to get these arranged so that they're the same base. This is 5 squared to the 2x. This is 5 cubed to the x minus 1. Again, if the bases are the same, that means that the exponents have to equal each other if they're equal on both sides. So I get 4x equals 3x minus 3. X is equal to negative 3. All right. So your first option is to, of course, change the bases so that the bases are the same. Then they want you to graph them. So look at that example 251. So we would graph y equals 7 to the x. And y2 would be equal to 3,579. You can find their intersection points. So they do that in method 3. Method 3 is graphing both and finding the intersection point to get the right graph. In method 2, it's interesting because so what they do is you've got this to begin with. You've got 7x equals 3,579. So if we made that equal to 0, I'd get 7x minus 3,579 equals 0. So if I were to graph it and find the 0, I graph 7x subtract 3,579, like that. Well, we just finished in 7.2, we just finished all our transformations. So what transformation does minus 3,579 do to the graph of y equals 7 to the x? Which way does it move because of that minus 3,759?
Is it down?
Yeah,
1,500.
that's right. That's exactly right. So we normally would go like this at 0 and 1. So now it's got to move down 3,579. So that would be, this would be negative 3,579 here. This would be negative 3,578 and 0. And then they want you to find your 0 in that case there. Okay, so that's in method 2. So you can do one or the other. You can graph two equations, so y1 and y2. Or you can graph it as one single equation and find out where the 0 is. Okay, this section is not too bad. I think 7.2 is a little more difficult than what 7.3 is. So let's skip back to 7.2 and find out where you needed assistance on 7.2. Any questions? Girls, anything from 7.2? All right. You need to have 7.3 completed. We want to get done 7.3. And then I will, that takes us to the end of 7.3. I'm going to combine 7 and 8 this week for your assignment on Friday, because I'm going to skip into this question right here. Leads us, that question right there leads us into logarithms. So that allows us to change bases. So this is all stuff that we did and applied. Okay. So I'm going to combine 7 and 8 this week on your assignment on Friday. So you need to finish 7.3 today. We'll start 8.1 tomorrow. Sorry. We'll start 8.1 on Wednesday. Tomorrow you'll do your review on chapter 7. Okay, it's not very long. It's 3 pages, 8 questions of review, and that's it. All right? Okay, so is there no other questions from 7.2?
I don't have any.
Okay. Okay. So what I'm going to do is I'm going to close this up this morning, and then let's get physics open, and I want to go through a few questions of physics with you. All right?
Did you get an assignment?
I did. Thank you.
Okay, I dropped it into OneDrive. I tried to do that, and I emailed it to you.
The email worked best, Daylin. If you can email that to me as a PDF, that's what works better.
Okay, good.
'Cause
because Miss Zhang, we've just been, like, I just scan it, and then she actually puts the assignments